This is the answer to Chapter 1, problem number 37 from the Smith Organic Chemistry textbook. And this problem gives us a ball and stick model of citric acid. And then we're asked to do 5 things with this ball and stick model. So we're asked what the molecular formula is, how many lone pairs are present. We're asked to draw a skeletal structure. We're asked how many sp2 hybridized carbons are present. And we're asked what orbitals are used to form each indicated bond. And there are 4 bonds that are indicated. So I'm going to take this a little bit out of order. So C asks for a skeletal structure. So I'm going to start by drawing the skeletal structure. I personally think skeletal structures are much easier to work with than like ball and sticks, for example. So to do this, you do just need to remember each red ball is an oxygen, each black ball is a carbon, and each white ball is a hydrogen. So I'm going to actually start over and make this a little bit bigger. There's no need to go so small. It will be easier to see and easier to draw well if I make it bigger. Okay, so there's the backbone. And we just have OH and another OH. Okay, so here's a skeletal structure. And actually, just for the sake of consistency, and remember, it doesn't matter. You can draw them separated with a line in between them, or you can just draw them next to each other like this. It amounts to the same thing. So that's part C, converting from the ball and stick model to the skeletal structure. So then for A, we're asked what the molecular formula is. So we just need to count. And when we do count, we find 6 carbons, 8 hydrogens, and 7 oxygens. So there's A, there's our molecular formula. To determine the number of lone pairs that are present, we should remember that each oxygen will have 2 lone pairs around it. If it's not charged. So when oxygen has 2 bonds, as each of these do, it also has 2 lone pairs. So I'm just going ahead and drawing all the lone pairs in blue. So you could either do 2 times 7, since you know that there are 7 oxygens after finding the formula, or you could draw the lone pairs in and count. But either way, you get 14 lone pairs, 2 each for 7 oxygens. Okay, and so the next question is D. How many sp2 hybridized carbons are present? So each carbon that has a double bond to an oxygen is going to be sp2 hybridized. So I will go ahead in red and indicate those. So this carbon is sp2 hybridized. This carbon is sp2 hybridized, and this carbon is sp2 hybridized. So the answer there is 3 sp2 carbons. Okay, and then lastly, we're asked to determine which orbitals make up each of these 4 indicated bonds. So let me go ahead and draw those in. So number 1 is this double bond. Number 2 is this carbon-carbon bond. Number 3 is this bond between oxygen and hydrogen there. And then number 4 is this carbon-oxygen bond. Okay. Oops, I didn't put a number here. Okay, so that's 3. So then over here on the right, I will list what each of these is. So 1 is a carbon-oxygen double bond, as I said. And so it is going to be made of C sp2 to O sp2, and then also Cp to OP. So remember, the second bond is a pi bond. It's 2 pi orbitals coming together to form that bond. So Cp to OP and Csp2 to OsP2. So indicated bond number 2 here is a carbon-carbon single bond. However, the 1 carbon is also double bound to an oxygen. So it's a carbon-carbon single bond. So Csp3 for the carbon that is only bound to other carbons and hydrogens. However, the other carbon is sp2 hybridized. So it's going to be Csp3 to Csp2. Okay? So then 3 is an oxygen-hydrogen bond. And that oxygen is sp3 hybridized. It only has a single bond to a carbon and this bond to the hydrogen. So it's going to be O sp3 to hydrogen. And remember, for hydrogen, we just say 1s. Hydrogen doesn't have any other orbitals. So then for 4, 4 is a carbon-oxygen bond where the carbon is not bound. So 4 is a carbon-oxygen bond where they're both sp3 hybridized. They both only are participating in single bonds. So it's going to be Csp3 to OsP3. Okay, and so that's all the parts of this problem. So the skeletal structure here, as I said, C6H8O7, 14 lone pairs, 3 sp2 carbons, which I've indicated with red arrows. And then the answers to each of the 4 bonds that I've indicated with green arrows and numbers. Those orbitals that are making those bonds are listed over here to the right. And that's the answer.